So in this video, I'm going to show you a few examples of integration by parts, and I'm specifically going to focus on examples where you have to use that formula multiple times. So I'm going to go through these two examples. So of course you can just fast forward to the one you want to see if there's a particular one that you would like to see. So let's start with the first one. So if you feel like you're a little weak on understanding integration by parts, please keep in mind I have a video where I break down this whole formula and explain like how to use it and why to make the choices that you make. This video is really intended to just show you more examples, so I kind of assume that you've got the basics down. Okay, so we need to choose our u and our dv, and we would like to choose a u that ideally, if we integrate enough times, would turn into a constant. And so in that case, that would be x squared. So if I take x squared, if I take the first derivative, it's 2x, and if I take the next derivative, it's just 2. So eventually, this is going to, I'm going to get enough derivatives here that this will no longer be a problem. And so then my dv is going to be this cosine x dx. Therefore, my v is sine x, and my du is 2x dx. And so now I'm just going to use the formula. So the formula is, the integral of u dv is uv minus v du. Again, if you don't understand this, I strongly recommend you just check out my lesson video. I really do break all that down. Okay, so I've got uv. It's going to be x squared sine x minus the integral of v du. So it's going to be 2x sine x dx. Okay. So now I can't go any farther with this. I can't integrate this, so I have to just use integration by parts again. So what I'm going to do is I'll just highlight this in green so that you can kind of track where I'm going with this. So now I've got to choose a new u and a new dv. So in this case, my u is going to be 2x, and now my dv is going to be sine x dx. Therefore, my du is 2 dx, and my v is negative cosine of x. So now I need to make some space. Okay, so don't forget the first part of the problem. So this x squared sine x minus, and now I'm going to put some parentheses around this so I don't forget to distribute the negative. So I go once again, uv, so that's negative 2x cosine x minus v du. Now, this will be minus negative, so this will actually turn into plus 2 cosine x dx. So that's my v du, and that flipped the sign here. Okay, and so now when I take a step back, I say, oh, I can actually integrate this, so I'm on the right path, so I just need to finish this. So this turns into x squared sine x, let's see, minus negative 2 cosine x plus 2 sine x plus c. And then I can just distribute the negative, so I have x squared sine x plus 2x cosine x minus 2 sine x. I can just write plus c. You don't have to worry about having a plus or minus with your c. You can always just write plus c because it's a constant, so it doesn't really matter. Okay, and so there's my answer to that one. So for the next one, I've got x squared minus 2x plus 1 times e to the x. So you might want to like spend a moment just trying to set this one up. When you do enough integration by parts examples, you kind of start to notice the rhythm to these. And so in this case, so this part here, this x squared plus 2x minus 1, this is going to be my u, and my dv will be e to the x dx. Okay, and so really, like, eventually we would like to break this down enough so that it kind of goes away, and so that's partially why we set it for u versus this dv. This is not going to really go anywhere, right? So you just kind of get a rhythm for this. So okay, so my du then will be 2x minus 2 dx, and then my v is e to the x dx. So I'm going to have uv, so that's x squared minus 2x plus 1 times e to the x minus v du. So that's going to be 2x minus 2 e to the x dx. Oops, I'm sorry, I threw an extra dx in here, my bad. Okay, so now that I'm here, so you can see like we're making progress on integrating here, because now instead of having something that's x squared, I have 2x minus 2. So we're just going to repeat the process. So now my u will be 2x minus 2. So my du will be 2 dx. And then my dv is still this e to the x dx. And my v is e to the x. Okay. So we just want to make sure we don't forget this part of the integral. So let's make some space. So I'm going to have this x squared minus 2x plus 1 e to the x. And now I repeat this. So I have my uv, which was 2x minus 2 e to the x, minus vdu. So that's going to be 2 e to the x dx. And now this I can just straight up integrate. So we're almost there. And so this is going to turn into x squared minus 2x plus 1 e to the x minus 2x minus 2 e to the x plus 2 e to the x plus c. Good times. Okay. And so we are going to leave it at that. So if you found that helpful, I'd love it if you hit that like button or the subscribe button. That'd be super cool. And otherwise, I'll talk to you guys in another video. Bye.